Alright, let's continue our discussion of kinetics by discussing the kinetic molecular theory and diffusion of gases. So, beginning this discussion, kinetic molecular theory describes the behavior of matter in terms of its motion. Okay, all matter is moving. Solids are vibrating, liquids are flowing past each other, and gases are freely moving. We're going to focus on kinetic molecular theory, mostly how it pertains to gases. Okay, so we have to accept 5 assumptions of KMT in order to use this theory to make predictions. The first is that gas particles do not attract or repel each other. So unlike solids that are very strongly attracted and locked in place, and liquids which are attracted and flow over each other, gas particles do not attract or repel each other. Also, gas particles are very small and they're separated by very large relative distances. Okay, so basically they're very separated, which means they have a low density. Next, gas particles move in straight lines, but they move in random directions until they collide with something. So the illustration that we see here, this animation, shows some sample collisions of a couple different types of gas particles. And you notice they're moving straight up until they collide. And you'll also see that they have various different speeds, and we'll get into how speed pertains. But the fourth point is that no kinetic energy is lost in these collisions. Okay, no kinetic energy is lost. In fact, we refer to this as these collisions are elastic. Okay, no kinetic energy is lost. They are elastic collisions. And the last idea is that all gases have the same kinetic energy at the same temperature. Okay, so if they have a constant temperature, be thinking in these terms. Temperature is really a measure of kinetic energy. Now, let's discuss one of the results of gas properties, gas behaviors. One of them is that diffusion occurs. Diffusion is when one substance spreads through another. Okay, and it isn't limited to gases. We could have diffusion of a liquid through another liquid. In this case, we're looking at dye being spread out through a liquid water sample. So liquid through a liquid, but it's one substance that spreads through another. An example of gas diffusion is we have a perfume, for example, and as we spray the perfume, some of the liquid perfume is going to vaporize and it's going to become kind of like in an aerosol form. It spreads out as a gas and it is going to randomly spread out throughout a room. Now, on a little bit more detailed molecular level here, we're going to drop in some dye into that liquid sample, so very similar to what we were looking at here. And at first, the highly concentrated clumped up particles are going to start randomly moving about, start breaking up a little bit, and that diffusion process is going to continue. It's going to continue spreading until our dye particles are evenly distributed throughout our water sample. So be aware that this random motion of gas particles, this is why gases diffuse through each other and completely fill containers. That's a cute little typo. They completely fill their containers. So please be aware, this random motion is the cause of diffusion, and that's why gases completely fill their containers. They keep moving until they're completely filled. So now let's do some practice. According to kinetic molecular theory, do intermolecular forces exist between gases? Well, KMT said that there were no attractions, so we would say that there are no intermolecular forces between gas particles. Describe the motion of gas particles. They are going to move in straight lines, in random directions, until they collide. And also, they're moving very, very fast. They have high energy. So what term indicates that no energy is lost in a collision? The term that we said is these are elastic collisions. Elastic collisions. Now, molecules of N2 and CO2 are trapped in a flask at 25 degrees Celsius. So here's our scenario. What do you know about the kinetic energy of these two gases? Well, what we know is the temperature. The temperature of these gases is 25 degrees Celsius. Since they're both this temperature, they are going to have the same kinetic energy. Because they're the same temperature, they're the same kinetic energy. Gas particles will spread out in random directions until they achieve we would say an even distribution. An even distribution, okay? Till they're evenly distributed.